Hello friends, Salman Naqvi here. Today I'm super excited to, for the first time, introduce you to the Bug Sniper. Bug Sniper is a AI-powered robot that detects bugs and shoots water at them. So it's a chemical-free bug repellent solution. It's still a work in progress. It's not fully working yet, but I'm getting there. Maybe about 60-70% done so far. So let me show you more about it in action. Right now it's in hunting mode, so I'm going to stop that so that I don't have to speak over the motors. And then I will show you the Bug Sniper in action. So this is a robot that's powered by a Jetson Nano AI computer that runs AI locally to detect a video feed that's coming in at 120 frames per second using this camera. And it's detecting all motion that's going in front of it. And then as soon as it detects motion, right now I have temporarily paused it so that we don't have to worry about audio. Then this camera zooms in into the motion, and then once it verifies that it is indeed an insect, not a human, not a cat, not something else, not a leaf, then using the solenoid valve powered by this motor, going through this pressure transducer and accumulator pump and check valve, it verifies, shoots precise amounts of water down to the millisecond at the target. There is an IR blaster, and this camera has no IR filter intentionally so that it can detect movement of wings of insects. And the whole thing is powered by the Jetson Nano, as I already mentioned. A dual relay is connected to the Nano to control the water pump, which connects to a water source. Obviously, right now it's not connected to a water source because it's sitting in my office. There is an ADS 1115 board that connects to the transducer, which allows the Jetson Nano to see the pressure. There's a Pico W board that's connected to the Jetson Nano that allows me to precisely control the solenoid valve, again down to the millisecond. And there is a PCB board that controls the servos that allow the whole setup to move, as you saw at the beginning of the video. All of that together comes together in perfect harmony to theoretically detect bugs. So as I mentioned, it's about 70% complete so far, and I'm still working through more accurately detecting bugs. And so it's not like these cameras so far are not great at accurately detecting bugs, and so that's something I'm still working through. Now I'll show you some of the software magic in action. And there's a fun camera, fun light on my head so that I can see what I'm doing. So this is where the magic happens. So what I'm gonna do is the robot is sitting right behind me. I'm gonna put it back in hunting mode. So I'm gonna put the robot back in hunting mode. And so see the light on my head, I can remove that now. I don't need it because I'm gonna sit on my computer now. And I'm gonna put it back in hunting mode. And so what it will do now is anytime it detects motion, it will move towards that motion. And once it detects what it thinks is an insect, then it will attempt to shoot water at it. Right now, it's just going to shoot blanks because there's no water connected because I don't want my computer or anything else in my office getting messed up. And I'm going to temporarily stop the hunting mode again to show you the rest of the software. So I've added a bunch of test fire functions so that I can check the progress and make sure that the solenoid valve, the transducer, the servos, and other functions are working. I can manually move the gimbal as well. There's a slight delay in the camera feed because it's coming over wireless. Jetson is connected to my wireless network. And it also shows the last several detected insect hits and misses. So it tells you when it missed and when it hit. And there has been a bunch of false positives in here. So that's the thing that I'm still working through. I've just added this insect training section, which is one of the next steps I need to do, where I will put real insects in front of it and see if it detects it successfully, and then train it to detect insects properly. I am using training data from not RoboFlow, to train Jetson to detect mosquitoes. And so that's something I have done already. But that original training data set, it's mosquitoes against a white background. So that is helpful, but now I also need to further train and reinforce with realistic background, like this in my backyard, for example, from a couple of days ago. There's a dedicated section for testing the solenoid valve. I had a lot of trouble getting that working because Originally, I had it going through a dual MOSFET, but then later it was burning out and I had a bunch of issues. And eventually, Pico W solved all those issues. There's an auto calibration setting in here as well, where I can set the amount of pressure the water should be at before shooting. So then when the water goes through the pipe, goes into the accumulator pump through the check valve into the pipe where it's going to the solenoid valve, there's a pressure transducer there to make sure that the pressure is always the same so that when the solenoid valve opens for 10 milliseconds or 15 milliseconds, which is just enough to get a drop of water out at 15 psi, then it's always consistently going to the same spot. So that was a big problem to solve that took a good few weeks to get set up. There's an auto calibrate function, which I'll just run for a few seconds, which shoots water at 10 random spots, and then it detects if that spot got wet. And if it got wet, then it knows that it's shooting at the right spot, and the pressure settings and the pulse settings set on the solenoid are all matching up. And we're going to get a bunch of misses right now because there's no water in there right now because obviously it's running in my office. And I will stop it so that it's not making too much noise behind us. And then these are some of the results from the last several auto calibration tests. So that there's a whole bunch of other tests in here that I set up to run test different components, because each component that's in there, the transducer, the ADS1115, the dual MOSFET, the PCB controller board, the Pico W, all of those things, they had to be individually installed and set up. So that's that. And then there's a universal settings page where I set the settings, which it will always use at runtime, which is separate from the testing and calibration. And then the calibration feeds into the universal settings as well. So that's the project so far. And I have put the project, made it open source. And you can see I have put a lot of work into it over the last several months. But basically everything I have done with this project so far is in here. So if you were so inclined to set this up in your home as well by getting all these parts, you could do so as well. And then there's just I'll also go over the journey of getting this set up. So I was inspired to build this. Then I ordered a bunch of parts and then used some parts from around the house as well. There's my cat, one of my two cats. And then started putting the thing together and trying to figure out what would work, how would I put the Jetson, how would it come together, what kind of components would I need. There's a Jetson Nano. It required assembly and setup. There's a pump, and now it's very messy, but this is initially what it looked like. And then I had to move things around. Originally, I was using a drone gimbal, and a drone gimbal was simply not strong enough to hold a heavy solenoid valve attached to a silicone pipe. So then I had to build my own gimbal using servos, basically using motors. And this is me getting the motor connected to the Jetson and controlling it. I had a LiDAR in there as well at one point. I shorted it and it melted, so I'm no longer using that. This was one of the early results of the drone gimbal in action. And you can see it was twitching. Even with the camera and LiDAR, it was a little bit too much weight. Then I did some counterbalancing, got that working a little bit, but it was still too much for the gimbal. So then I had to switch and pivot and try different methods. And so then I had to move to servos. And so these are the servos that are connected to the PCB board. The PCB board is used to control the servos. And so that's installed for the first time there and in action for the first time there, and doing a pan test there. And then this was one of the first times I was doing a test with actual water. And then I realized that the original plan I had of just shooting the water with the motor alone was not precise enough because it was shooting large streams of water and I needed to control the water more precisely. So then I installed a nozzle, and that nozzle was also shooting streams of water, although more precise streams of water. And instead of shooting, when I was trying to shoot consistently at the same spot, instead of shooting at the same spot, it would shoot in a line, but not at the same spot. So then I had to pivot again and install a device that can add some pressure to it. And that's just me I burnt through a bunch of these MOSFETs in the process as well. So many short circuits. This is another fun short circuit because I'm not an electrician. I do cloud security engineering and automation as my day job. And so that's the dual MOSFET. And there were some places where leaks were happening. You can see more short circuits there. That wire had completely burned through. So eventually I got those things figured out. I had some issues with this board S1115, and I think I shorted it or something during my initial soldering. My soldering skills have definitely gotten better. So this is the good example of that. The left one is not functional, and it's no surprise why. And then I watched a couple of YouTube videos on how to solder properly, and then I got the results on the right. And the short version is you just hold the soldering iron against the pin that you're soldering, and then on the other side of that pin, you touch the soldering material, and then it turns into a nice even blob. And then you just hold it there for another second or two, and then you get these pristine connections that are much less likely to fail. So this was one of my first tests outside, and I was still running into some issues with the water not being shot properly, and there were some leaking issues as well. And one of the issues I was running into was that the pressure was not being maintained. So then I had to add a check valve. These things I'm learning as I'm going, building the solution. It just simply allows water to go in one direction but not the other. And that's what it is. And so then that helped maintain the pressure a little bit better. And this is just the same app that we saw here, just on the phone, exactly the same thing. And now the pressure is being maintained a little bit better, but still not perfectly because there's still some leaks. So I need to talk to a couple of maybe one of my plumber friends to figure out. But now we are at a point where water is being shot at the chosen location precisely, reliably. As you can see, just the tiniest amount of drops of water are coming out as we intend. And based on the latest test, water is being consistently shot within 2 or 3 square centimeter area, maybe even 2 centimeter area. And if I do like a pulse of 2 or 3 shots at once, it will reliably hit an insect. So my next challenge is basically figuring out how to make the system more accurately detect insects in an actual outdoor setting. So I've done some field tests in my backyard, did some field tests overnight as well, and there's a lot of false positives. So basically the data that has been fed with the machine learning algorithm, thanks to our friends at RoboFlow, not sponsored by them or connected to them in any way. The data they have provided is good, but it's just mosquitoes against a white background. And so I need to further improve on that, train and detect on a background that's might be seen in a more typical backyard or any other outdoor setting, and go from there. So hopefully that was exciting for at least some of you, and I've done a lot of this work so far without any updates, but I'll do some updates from time to time as I'm making progress on this project. Thank you for watching.